Hey everyone, and welcome to this explainer. Today we're taking on a really fascinating topic that actually trips up a lot of young science students. But don't worry, by the time we're done here, you're gonna be absolute pros. We are talking about work and energy. Okay, so let's just dive right in. In our everyday lives, we talk about doing work all the time, right? Vacuuming the living room, carrying a totally stuffed backpack around school, or even lifting weights for sports practice. But what if I told you that in the world of physics, a lot of the things you consider exhausting, back-breaking work actually equal absolutely zero work? Literally zero. That's right, the physics definition of work requires a complete 180-degree flip of how you usually think about it.
Think about the everyday world for a second. Imagine a builder who has spent the entire day building a massive brick wall. At the end of the shift, that builder is going to wipe the sweat off their forehead and say, "Wow, I did a lot of hard work today." And honestly, nobody would argue with them. Or imagine a weightlifter holding a massive barbell steady above their head. Totally exhausting, right? But here is our giant physics mythbuster for the day. According to the strict, unbreakable rules of the physics world, that builder and that weightlifter might have actually done zero work. Crazy, right? So how is that even mathematically or scientifically possible?
Section 1. Physics versus everyday work.
Well, the absolute crucial point here is how we define our terms. In physics, work has a really specific definition. Work is the energy transferred by a force in its own direction. Let me just repeat that real quick because it's basically the golden rule of today's explainer. In its own direction. To put it simply, when you displace or move an object in the exact direction of the force you're applying, you've officially done work according to physics.
Imagine doing some heavy chores, like pushing a couch straight across the living room floor. You put your hands on it, and you exert a strong push, a force, straight forward. Because you pushed straight forward, the couch slides straight forward across the carpet. Your force and the couch's displacement are in the exact same direction. Boom! Congratulations, you've just done physics work.
Section 2. The formula for work.
Now, as your science tutor today, I gotta tell you, we can't just talk about these ideas. We have to prove them with math. But don't worry, it's pretty simple. Here is the formula that runs the whole show. Work equals force times displacement times the cosine of the angle between them. Written out, that's W equals F dot D dot cos theta. Now, a super important note here. Work is what we call a dot product. Let's break down the ingredients. F is the force you exert on an object. D is the displacement, or basically how far the object actually moves. And hey, don't let that little theta symbol intimidate you. That's just a fancy math way to talk about the visual alignment between the direction of your push and the direction the object moves.
You see, it all comes down to the angle. If your force and the movement are perfectly aligned, the angle between them is 0 degrees. The cosine of 0 is 1, which gives you maximum positive work. But what if you push one way and the object moves at a right angle to you, 90 degrees? Well, the cosine of 90 is 0, and anything multiplied by 0 is 0. Finally, if they completely oppose each other, forming a 180-degree angle, the cosine is -1, and that results in negative work.
Let's walk through the math of a maximum work scenario so you can really see it in action. Let's say you exert 10 newtons of force on that heavy couch. It travels 20 meters. Because the direction of your force and the direction of the displacement are exactly the same, our angle is 0 degrees. We plug it right into our dot product formula. 10 newtons times 20 meters times the cosine of 0, which is just 1. So 10 times 20 times 1 equals 200. Your work done is 200 newton meters, which we call 200 joules. Simple, clean, maximum work. But here is where we fall into the trap. Let's say you exert a massive 50 newtons of upward force to lift an object, say your super heavy backpack. You are really straining, and you end up walking horizontally 30 meters down the hall. However, your force is pointing straight up, and your movement is completely horizontal. That creates a 90-degree angle between the force and the displacement. We plug it in, 50 times 30 times the cosine of 90. But wait, the cosine of 90 is 0. 50 times 30 times 0 equals 0 joules. This is exactly why walking down the school hallway while carrying your heavy backpack mathematically equals 0 work. The direction of your lifting force and the direction of your walking displacement are completely different.
Section 3. Positive and negative work.
Remember earlier when I mentioned that work can be a scalar quantity? Because it's scalar, it can actually be positive or negative depending entirely on that angle. When force and movement perfectly match, we get positive work. But what if you exert a force in one direction and the body is displaced in the exact opposite direction? The angle between them is 180 degrees. Since the cosine of 180 degrees is -1, the resulting calculation gives us negative work.
Let's apply this to the real world. Think about lifting a really heavy object straight up from the ground. While you are pulling up, doing positive work, gravity is doing something else entirely. The force of gravity is pulling straight down, but the object is moving straight up. That's a 180-degree difference. Therefore, the work gravity is doing on that object is negative work. It is literally fighting against the movement.
Section 4. Energy and kinetic motion.
So, if work is the action, energy is the fuel. Energy is quite simply defined as the ability or the capacity to perform physical work. You can't displace an object, you can't exert that force without the capacity to do so. In our daily lives, we get energy from the healthy foods we eat, giving our bodies the fuel to perform physical tasks like sports and chores. In physics, energy is the fundamental currency required to make work happen.
Let's connect the dots here. When we do work on an object, we're essentially displacing it from its resting position. And when we displace it, we are producing motion. As you probably know, a body in motion possesses kinetic energy. Therefore, when you do work on an object, you are actively transferring energy and changing the kinetic energy of that object. By pushing that couch across the floor, your work literally injected kinetic energy into it.
And because work transfers energy, they share the exact same unit of measurement, the joule. Whenever you're calculating work or calculating energy, your final answer is always going to be expressed in joules.
So what exactly is one single joule? We've talked about 200 joules and 0 joules, but let's break it down to its absolute simplest, easiest to remember form. 1 joule is equal to 1 Newton meter. In plain English, if you exert exactly 1 Newton of force on an object, and that object is displaced by exactly 1 meter in the same direction, you've done exactly 1 joule of work. It's the perfect foundational building block of all this physics math.
Section 5. Practice time. Work or not.
All right, my awesome science students, we have covered a lot of ground today. We've talked definitions, dot product formulas, and those tricky trigonometry traps. Now, I want to challenge you to a quick, interactive review session just to test your new physics instincts. Here is your first scenario. You're doing a household chore. You push a heavy vacuum cleaner straight forward across the carpet, and it moves straight forward. Work or not? Take a second. Have you got your answer?
Yes, absolutely work. Because you pushed the vacuum forward and it moved forward, your force and the displacement were perfectly aligned. The angle was 0 degrees, the cosine of 0 is 1, meaning you achieved maximum positive work. Great job if you got that one right.
Okay, let's try a trickier one. You pick up a heavy tray of food in the school cafeteria. You're exerting an upward force to hold it steady, and then you walk horizontally to your table. According to physics, work or not? Think about the angles we talked about earlier.
0 work. That's right, you fell into the 90-degree trap because your upward lifting force and your horizontal walking displacement were completely misaligned at a right angle. The cosine of 90 degrees kicked in, and since the cosine of 90 is 0, the entire equation zeroes out. This is exactly why carrying that cafeteria tray horizontally mathematically equals 0 work. And that brings us to the end of our lesson today. We've completely flipped how we understand everyday chores versus scientific formulas. We know that work requires alignment, that angles literally change everything, and that doing work physically transfers energy to create motion. So whether you are tackling chores at home or bringing your A game to sports practice, remember that doing work transfers energy and creates motion. So what kind of positive work will you put into motion today? Keep that curiosity going, and I'll see you in the next explainer.